latest technologic innovations today.
And you don't have to pay.
Expert panels with advanced degrees are sure to satisfy your curiosity.
Did we mention it's free?
And if you think you'll find a better time than this, then come on down and test your hypothesis. Cause you're gonna learn a lot if you wanna stay down at the Science Cafe.
Hello, and welcome to Science Cafe, New Hampshire for November 2021, as we continue our series of virtual sessions. This is our 11th year of organizing Science Cafe, New Hampshire, and monthly sessions since May 2020 have gone virtual. My name is Rick Irving. It's my pleasure once again to be your host and moderator for tonight's topic entitled Artificial Intelligence Today. What is it and what does it mean? Artificial intelligence is a rapidly growing and evolving technology that's creeping into many facets of our lives. We hear about AI in hiring, college recruitment, tutoring, travel, and it seems new applications every day. We hear ads that talk about solving previously unsolvable problems and computers that diagnose better than the best doctors. While there are some incredibly beneficial advances, of course, what are we supposed to believe? And will the metaverse take over the world? We are very fortunate tonight to have an expert with us that is at the forefront of the development of artificial intelligence-related products with a keen awareness of the ethics involved in constructing these powerful tool sets. Susanna Shattuck is currently head of product at Credo, who helps organizations build and run AI that meets the highest ethical standards. I'm not sure what that means, but we'll be sure to ask her. For those in our audience that are new to Science Cafe, first of all, thanks for tuning in, and let me quickly tell you about our program and some of the procedural comments. The goal of Science Cafe is to engage the public in a dialogue with experts on science-related topics and engage in a conversation that clarifies understanding and addresses audience concerns. You can actively participate in the discussion by using the comment section of Facebook or YouTube to submit your questions to us for the panel. Our colleagues will collect them and forward them along to us for discussion. Please be succinct with your questions, and if you would, please include your name and location for general interest purposes only. You may start submitting your questions now and for the remainder of our session tonight, and we'll get to as many as we can. Tonight, we have a little bit of a different twist. We have a single panelist whom we are very excited to have join us, and we'll be breaking the conversation into two parts, each with an introduction by Susanna. First, she will cover exactly what AI is, how it's built, and the basics of what AI systems are today. Then we'll pause, take some questions, and in the second half, Susanna will introduce the difference AI systems can and will make in our lives, how will they be used, and what do we mean by fair, equitable, biased, or ethical AI. And again, we will have time to take your questions. So now I would like to introduce Susanna. So Susanna, welcome. We're so happy to have you here.
Thank you so much. It's wonderful to be here, Rick, and thanks for that great introduction.
Oh, you're welcome. So for the audience, Susanna Shattuck, we have here. She got her undergraduate degree from Yale University, her MBA from Stanford University, and she has a lot of artificial intelligence experience already. She is currently the head of products at Credo AI. She was also director of products at Arthur, an advisor at X Moonshot Factory, and the product manager for Watson's OpenScale product set. So Susanna, why don't you go ahead, take a few minutes and tell the audience about yourself and what your interests are and how you got into this.
Perfect. Sounds great. And thank you everybody for joining us this evening. So as Rick mentioned, I've been working in the AI space now for a while anyway, for the AI space. It's relatively nascent technology, still very much maturing. My career in AI started back at IBM. I joined IBM Watson's implementations team back in 2016. And 2016 was right around the time when a lot of organizations, a lot of companies started to realize that this AI thing wasn't going away. It was only getting bigger, and that they started to need to find a way to incorporate that into their business. And of course, Google, Amazon, Facebook, the big tech companies had already been doing enterprise level AI for a number of years. But for more traditional companies in traditional industries, everything from hospitality to insurance to healthcare, there was less experience and familiarity with AI. So my role on the Watson implementations team was to meet with executives from companies, mostly Fortune 500 companies, and help them understand, first of all, what AI was, so exactly what we're going to be doing here tonight, and then help them develop an AI strategy and identify the first few use cases that they wanted to address with their organization. And let me tell you, after working in that role for 2 years, I have seen pretty much everything go wrong that can go wrong with an enterprise AI system. And that's why I became so passionate about responsible AI and AI governance and AI ethics. I started to realize that if we're not baking these concepts and these issues into our development process from the beginning, we're going to end up with some pretty terrible systems out there in production.
Well, I think we're going to cover a lot of that in the second half of this, and I'm very anxious to hear that. But as we told the audience, we're going to do this in 2 parts tonight. So would you like to introduce the first part of what is AI and how does it work?
Perfect. Yeah. So the way that I like to talk about AI is first by talking a little bit about how programmatic computing systems work, and then talking about how machine learning systems are different from programmatic computing systems. I think one of the biggest myths about artificial intelligence is that there is something magic happening under the covers, that these systems are brilliant or smart in some inherent way. I'm hoping that over the next 10 minutes or so, I can debunk that myth for some of you if you've heard that before. But first, to start about how programmatic computing systems work, how computers work in the first place. So a programmatic computing system is a rules-based system. It's a system that follows a very simple set of rules that have been encoded, that have been written by a programmer, a developer. And those rules usually follow the format of if this, then that. It's a rule that specifies if some particular thing happens, then the computer program should do this other thing. So I'll give you an example. Microsoft Word, one of our favorite programmatic computing applications, right? Microsoft Word has a set of rules that define how all of the different buttons in the UI should trigger different actions. So for example, there's a rule encoded into the Microsoft Word software that says if the user clicks the save button, then Microsoft Word as a program should save a new version of that file in the same location that had been previously specified by the user. It's a very simple rule. It happens every single time in the same way. So that's programmatic computing. But what about machine learning? What about artificial intelligence? So a machine learning system is designed to perform tasks that cannot be distilled down into simple rules. I'll give you an example. A very common machine learning use case, a common AI use case, is computer vision, a system that can look at an image and predict what is contained within that image. The classic example that's always given on the internet is a system that can look at an image and discern whether or not a cat is present in that image. The internet loves cats. Now, if you were going to write a rules-based system to detect whether or not an image contained a picture of a cat, what are the rules that you might write? Well, you might say, okay, if you see something that looks like whiskers, then it's a cat. If you see something that looks like ears, then it's a cat. If you see a tail, then it's a cat. But all of those characteristics that I just described also apply to other animals, dogs, foxes. And so you quickly come to realize that a rules-based system for something complicated like image classification is actually not going to work. And so that's where machine learning comes in. Machine learning is about using pattern recognition to perform tasks as opposed to using rules to perform tasks. A machine learning system is trained to recognize patterns in data. There are a few really key concepts in that sentence. The first concept is data. A machine learning system is only as good as the data that you use to teach it the patterns that you want it to recognize. So for example, if I want to train this AI system to recognize images of cats, I need to have a very large and very comprehensive data set of different types of images of cats so that my machine learning system can recognize images of cats even in contexts where it might be nighttime, there's not a ton of light, even in contexts where the cat is a hairless cat, it doesn't have any fur, or where it's missing a tail or missing an ear. And if your data set is not comprehensive, is not representative of the real world, then your machine learning system is only going to be able to recognize the patterns that are contained within your data set, and they won't be able to recognize the patterns of the real world. So data is a really, really fundamental component of how AI systems work. The other key piece that I talked about was this concept of training. So a machine learning system can learn patterns in two different ways. There's something called supervised training, supervised learning, and unsupervised learning. And these are basically two different ways of training your machine learning system to recognize patterns. Supervised learning means that I have all the answers, and I want to train my machine learning system to know the answers as well as I know them. So in the cat example, it would mean that I have a whole set of pictures that I know contain cats, and I have labeled each of those pictures to say that it contains a cat. And I show my machine learning model, this is a non-technical term, I have my machine learning model ingest all of these images that have been labeled as images of cats, as well as a set of images that have been labeled as not cat, images of rocks and rivers and dogs. And based on the direction that I give my machine learning system, it learns to recognize the patterns that make an image labeled cat and the patterns that make an image labeled not cat. That's supervised training. Now there's also unsupervised learning, which means that I don't have the answers. And I want my machine learning system to go out there and just try to find interesting patterns on its own. And then I'm gonna go and try to analyze those patterns to see if they're useful. And a great example of where you might use unsupervised learning is in a case where you want to use a machine learning model to try to group different groups of customers into customer segments. This is a really common use case in the context of retail. We all buy a lot of things on Amazon probably. If you buy things on Amazon, you are unconsciously training Amazon's algorithms about what you like to buy. And Amazon is going to do their best job, because this is how they make money, to predict what you might want to buy next and suggest that to you, maybe at a special price to try to get you to buy more. And so they are going to use a combination of supervised and also unsupervised learning models to say, okay, we don't know who Susanna is as a buyer, but here are a whole bunch of other people. Try to figure out, machine learning model, where Susanna fits in. How do these people cluster into different groups? And then how might I be able to use those clusters to do specific marketing to somebody who looks like Susanna? And so that's an example of unsupervised learning. And it's a very important thing to understand that a machine learning model is trained on data in order to perform a task. There is no system that is going to do something out of the box with no training and no data. There is no system that is going to be able to teach itself, as the headlines sometimes say. There's always a human involved specifying how that system is going to be trained, what they're training on, what that data is, and ultimately what their objective is. So at the end of the day, I hate to break it to you all, but artificial intelligence is really just math. It's just statistics. It's pattern recognition at scale. And that's how these systems work.
Very interesting. Okay, I was actually going to ask you the difference between machine learning and AI, so I'm glad you covered that already. Now,
well, I didn't. Maybe I didn't do a good enough job. So that's a really important art of terminology. So machine learning refers to a specific set of techniques, technical approaches to creating systems that can learn how to recognize patterns. And artificial intelligence is a broader umbrella term that includes machine learning as one approach, but it also includes other approaches to trying to build computer systems that can behave in ways similar to how humans think. Now, I hesitate to say behave in ways similar to how humans think because I cannot emphasize this point more. This is the most important point. If you take anything away from tonight, please take this away. Our versions of artificial intelligence, our rudimentary systems that we are building today, are miles away from any kind of even remote semblance to human intelligence. The systems that we're building today do not understand logic. They do not understand reasoning. They do not have any kind of innate understanding of the world. They are purely pattern recognition systems. Now, there is a class of thinkers in this space who believe that eventually, through research and continued development, we will be able to develop smarter and smarter systems. We will be able to approach a version of what's known as general artificial intelligence that looks a lot like a human, that thinks like a human, that communicates like a human. But we are miles away from that today. And so I think it's very important to understand that there's a big difference between what you see depicted in sci-fi when we talk about artificial intelligence and what I like to refer to as the machine learning systems of today, because I think machine learning does a little bit of a better job of communicating what these systems actually are.
Okay, well, thank you. And that leads perfectly into our very first question, which is,
wonderful.
What are the next technological enhancements to what we know as AI today?
Great question. Depending on who you ask this question, you're going to get a lot of different answers, because the reality is that there are researchers in every corner of the world, at every academic institution, and within large private companies as well, that are working on new technological developments within the AI space. I'll say that there has been a long period of AI development that has been focused on having AI systems reach parity with human capability. And so when I talk about parity, what I mean is that there are general benchmarks that evaluate how well humans classify images, for example, or how well humans can dictate text, or record text that's being spoken. And for a long time, a lot of AI development has been focused on building systems that can be as good as the people are at those tasks. And the exciting news is that in the last several years, for many of those benchmarks, we've actually surpassed human capability with our machine learning systems. And so now these systems are actually better than humans at doing things like you referenced in your introduction, identifying cancerous cells within a CT scan or an X-ray, or dictating text that somebody is speaking into written word. We have machine learning models now that are better than humans at those tasks. So there's now another wave of AI research and development that's focused on trying to increase the efficiency of these systems. Now that we've done better than humans, let's figure out if we can do better than humans more cheaply. And when I say more cheaply, I mean with less training data and with less compute power. So one of the things that we can talk about more in the ethical implications component of this evening is that AI systems can be very expensive from an energy perspective to train, because you have billions and billions of data points that you're feeding through this system. And that takes a lot of compute power. It takes a lot of energy. And so there's an increased focus on trying to figure out how we reduce the number of data points that it takes to train a system that is just as good as the system that has been trained on a massive data set. So that's another area of research. But we could go on and on about the different areas of AI research all day. I'll pause here and see if there are any other questions.
We have one. The next question is actually by somebody that knows a little bit about this, it appears. AI works largely by combining various data sets with blazing computation. How does AI gain access to diverse independent data? And is there now a common API?
This is a great question. And honestly, it's one of the biggest challenges, particularly in thinking about the space that I'm working in responsible AI. How do we ensure that we're not just using the same data sets over and over again to train these systems? Data sets that often have inherent societal bias encoded into them, data sets that might have certain IP challenges associated with them. And unfortunately, I don't think there's a single good answer to this question today. There is an increased focus in the research community to develop more open source data sets that are available for researchers, for industry to use to train their models, but there needs to be more work done. The challenge is that a lot of the data sets that are developed by academia, these open source data sets, are developed by scraping the internet, pulling down all of the tweets from Twitter, pulling down all of the text from websites. And there's a lot of problematic content contained within that data that hasn't been evaluated, that hasn't been cleaned, that hasn't been, swear words haven't been removed, racist remarks haven't been removed, sexist remarks haven't been removed. So that's a really big challenge, and something that IBM, my former employer, got into a lot of hot water for, and had to sort of come up with a strategy to figure out how to fix. A lot of the computer vision data sets are pulled from websites like Flickr, where people have been uploading images since the early 2000s with no concept of consent that their image was going to be used for training a machine learning model. So we need to have new models of consent as well, baked into the way that we're handling data in the world. There is no common API at this moment in time. There needs to be a better way to address this problem.
Is there some sort of a standards board in place or being thought of that would be able to do that sort of thing?
Wow, Rick, it's like you're doing a perfect segue into the second component of the conversation. There are a number of different efforts right now to establish standards. And my company, Credo AI, is actually one of the organizations that's trying to support and facilitate the establishment of standards within the industry. NIST, the National Institute of Science and Technology, is actively developing standards around AI. IEEE, the Institute of Electrical Engineer, I can't remember what the third E stands for, but IEEE is developing a set of standards around AI. And then, of course, you have regulatory bodies, both the US, of course, the EU with the new EU AI Act, the US with the Algorithmic Accountability Act, and other government bodies like Singapore really actively participating in establishing regulation that will help to drive these standards. But it's early days. It's early days. It's the best analogy that I can think of is that it's sort of similar to how the cybersecurity community had to come together to establish a set of standards. And for a long time, there was no consensus around how we could ensure that our systems are secure and sort of prove to one another that our systems are secure until the emergence of SOC 2, which is now the industry standard for a set of compliance steps that you have to go through to ensure that your systems meet cybersecurity requirements. And so we need the equivalent for responsible AI development. We need a set of standards like SOC 2 that everybody comes together to agree on and to prove to one another.
Okay, so back to our audience questions. But isn't the analysis of tons of data points being analyzed similar to Word being told to save a document, all programmers set, and where does the AI come in?
Great question. So you're absolutely right. AI systems are fundamentally human-developed systems. Humans define the objective. Humans tell the system what to look for. And the AI component, the machine learning component, is really about being able to recognize patterns at a scale that far exceeds human pattern recognition. And when I say at a scale, I mean in the context that I gave before of image recognition, of classifying images that contain cats. We're talking about at the per pixel scale, not the whole picture, looking at each pixel of the image and determining what combinations of pixels mean that there is a cat present in the image. That level of pattern recognition and statistical analysis, again, is mostly where the computer capabilities far exceed the human capabilities. And so machine learning is really all about being able to apply those statistical approaches to specific problems. The humans define the problems that those statistical approaches are being applied on, but then those statistical approaches far exceed human capability in terms of being able to reproduce outcomes, actually identify patterns in the real world on data that they've never seen before.
Okay, well, we're actually going through this pretty quickly. I didn't realize I'm going to have a fascinating time talking to you, and I'm sure we could talk for hours. The next question, I think, leads into the second half, though. So the question is, should we be worried about artificial intelligence, and what are the downsides? So if you were to introduce the second part, how would you do it?
Great. So I think there are a few different things that I am concerned by when it comes to AI, and there are a few things that I'm excited about. And I'll start by talking about the things I'm concerned about and then lead into the things that I'm excited about. So the number one thing that I'm concerned about when it comes to artificial intelligence is exactly this problem of a human-defined system that has incredible analytical capability, incredible pattern recognition capability, being applied in a way that is going to hard code the challenges of our human decision making. And what I mean by that is there's this general sense that an AI system is somehow objective, right? But the reality is that an AI system is actually incredibly subjective based on the decisions that humans have made around what data it should be trained on, what it should be trained to do, what its objective function actually is, and how it goes and is used in the real world. And so I am worried about the ways that we place weight on the decisions made by, or the predictions made by artificial intelligence systems, by machine learning systems, because we have this fundamental belief that somehow they're objective. And this is where issues around fairness and unintended harmful bias come into play. I'm sure you've all read headlines that talk about the racist or sexist algorithms that have gotten released into the world. The reality is that the algorithm wasn't racist or sexist. It just learned to recognize patterns that exist in our world because we have a very long history of racism and sexism around the world. And so the great example of this, right, is there's an example that a lot of people give of a model that was trained at Amazon to analyze resumes and predict whether or not a resume was going to be a good candidate for a role. And the system turned out to be inherently biased against any resume that contained the word women's, like women's soccer or women's college or women's group, which meant that this system was biased against women's resumes. And it turned out that the system had learned this because, lo and behold, the vast majority of historical resumes from good Amazon candidates had come from men. They didn't train the model on very many women's resumes because the historical data didn't contain very many women's resumes. And so that's a perfect example of how we're hard coding some of our very human, very subjective and problematic view of the world into these AI systems and then tending to treat them like objective truth. I think that's a huge danger. Now, the next fear that I have about AI systems is that these systems are actually, as I mentioned before, not very intelligent. They're very narrowly focused. They're really only able to do one thing well. It's rare that you have an AI system that has transferable capability across many different domains. But I think that's another area of research. But the reality is that these AI systems are pretty brittle. You train them to do one thing and they do that one thing really well. But if you want them to do anything else, they're going to fail. The reality is that an AI system that's trained on, a self-driving car, that's trained on pictures and data from a single city, really is going to do a great job of driving in that city, but it doesn't do a good job at all of driving in any other city in the world. And so that's why we see that self-driving car companies are launching their products in single cities, mostly in Arizona, because they haven't gotten that transferability yet. They haven't figured out how to train the system to do well everywhere. And so my other fear about AI systems is that we're placing too much responsibility and trust in these fairly brittle machine learning systems that really are only able to perform well in a very narrow space. And so I warn anybody that's trying to start a machine learning project or implement machine learning in their organization, I warn them that to be successful, they have to define a very narrow scope for their project. And they have to be confident that they're going to be able to handle just that narrow scope. There's not going to be anything outside of scope, because the machine learning system is not going to be able to do well if it has to handle a very diverse set of inputs and produce a diverse set of outputs. And I think that's not something that's very well understood, especially by the public. And so that's another big concern of mine. Now, there are several things that I'm really excited about when it comes to AI that I think if we can overcome these fundamental challenges of believing that AI systems are objective and that they somehow know the truth. And we can recognize that we're hard coding our own human biases and human subjectivity into these systems by developing them in the first place. I think there is tremendous good that can be achieved by applying AI, particularly to spaces where the AI system or the machine learning system is helping a human make a better decision. Healthcare is an incredible example where we've been able to show in studies that a doctor that has an AI assistant helping them analyze x-rays and CT scans is going to do a better job of detecting cancer or detecting an issue than the human doctor does alone, or even the AI system does alone. It's that combined expertise that really unlocks the power of these machine learning systems. And I think it takes a lot of humility for a human expert like a doctor to recognize that a machine learning system might make them better. It also takes a lot of humility on the part of a machine learning engineer, somebody who's building the system, to recognize that they need to build it for a human to use, not for it to just go out there in the world and make decisions on its own. I think we need a lot more humility when it comes to developing AI systems to avoid some of the biggest and most challenging pitfalls with them.
Okay, that's a great point. So now, how pervasive are AI systems? As an expert here, do you come across applications that you see in your daily life and do you think, okay, I know what they're trying to figure out, or would I see one? Where would I find one that's trying to analyze?
Everywhere. Let's see, do you have an iPhone?
I have a smartphone.
Or an Android? Do you have a smartphone of some kind?
I do.
Great. And do you have a predictive autocorrect text on your phone that sometimes tries to correct when you make a typo?
Yes.
That's a very simple machine learning system that's learning from the words that you most frequently type to try to predict what you're trying to say when you type a typo. So I'll give you an example. My partner's name is Roberto. And so whenever I type the name Robert, my phone tries to suggest Roberto because that's the name that I more frequently type. And so even when I do actually want to type the name Robert, it suggests Roberto because it has learned from my behavior over time. That's a very simple example. Or I gave you the example of Amazon before. Any online retailer that is trying to do well in 2021 is using machine learning of some kind to try to predict what you want to buy and push you to buy that thing. So, if you've noticed that you are searching on Google for something and then you start getting emails about it in your inbox, trying to suggest for you to buy, that's all based on machine learning. That's based on your data and your behavior being used to train a system to help you make that purchase.
Great, thank you. Okay, so our next question is from John Beckwith. Should we be concerned about the amount of data Facebook and Google have on us already?
Great question. There are a couple of different takes on this in the community. I think the biggest concern that I personally have on Google and Facebook having this massive amount of data is that there's very little accountability right now for how that data is being used. And that's something that the regulatory environment is trying to correct with regulations like GDPR, and in California we have CCPA, which give consumers the right to, for example, ask these companies to delete their data, give consumers the right to understand how their data is being used. But the reality is that these regulations aren't very well enforced, and so they're not very effective. And I think the challenge with the kind of data monopolies that an organization, particularly like Google or Facebook, have over all of that data that we've provided them over many years is that it tends to stymie the ability of other organizations coming about and challenging these companies. It tends to restrict the power that consumers have to demand better services or better data treatment from others. So those are my biggest concerns, is this lack of accountability. Now, there's another group of people who are maybe a little bit more extreme activists than I am, who believe that people should really be compensated for this data that we've been giving these tech companies over many, many years. And I think it's true. Our data has enabled Facebook and Google to create, and Amazon to create tremendous amounts of value for themselves. Trillions of dollars of market capital has come directly from your data that you've inputted into these systems. But the reality is that the value of your data as an individual data point is not very high. And so the compensation that you would receive for your individual data from Google would be potentially fractions of a cent or cents on a dollar. And then the other challenge there with compensating people for their data is that I think that tends to incentivize the wrong things. It monetizes data privacy in a way that I think data privacy should be a universal human right. And so I do not want data privacy to be a privilege of the rich and the poor to be incentivized to sell their data for money. So it's a very challenging question to figure out how we actually bring about data accountability and give people power over their data without incentivizing the wrong things.
Okay, and the next question follows right into that. What can the average internet user do to circumvent the AI that is following us?
So there are a bunch of things that you can do. There are a number of third-party services that you can use to turn off different tracking tools. I do want to quickly specify that there is a difference between data tracking and very simple sort of tracking your behavior across different websites and sharing that data with different websites, and machine learning systems, AI systems. And data tracking is incredibly pervasive. Machine learning systems are generally something that are operating within a website or a product. And so they're not necessarily going to be following you across the internet. They could be consuming data from you across the internet and trained on data from your behavior across the internet. But that's much more the world of data tracking systems. And so data tracking systems, have existed since well before anybody was doing machine learning at scale. Cookies have existed on the internet since forever, since the beginning of the internet. And there are a lot of different tools that you can use to turn those off. I use a tool called Ghost, which shows me a little toolbar on every website that I visit, all the different cookies that are tracking me and enables me to turn them on or off. Apple actually just released a set of features that enable you to turn off data sharing for specific apps. So you can, for example, tell Instagram that you don't want Instagram to get access to any of the data from your other third-party internet providers. And those are some of the ways that you can sort of take control and turn off the tracking. I will say that your experience using the internet and using those apps is going to be markedly less personalized. And so for some people, they really value their data privacy. They don't care about the personalized experience, the benefits that they're getting from sharing their data. But for other people, they turn off the tracking and they realize that they actually miss some of the benefits that they get from that. So it's really up to you to figure out what you value and what you care about.
Okay, very interesting. I didn't know that they had things like that. So our next question, discuss how AI and facial recognition go together.
Great question. So facial recognition is one particular application of machine learning technology, very similar actually to the use case that I gave around recognizing cats. Facial recognition is another type of computer vision where we are trying to identify something within an image. And there are a couple different flavors of facial recognition. There's simple face detection, which is basically saying, is there a face present in this image? There's face classification, where you're trying to understand what type of face is in the image. So for example, you could have gender classification as part of that. You could have age classification, trying to identify what the gender and age of the face is in the image. And then you have face matching, which is, I think, what a lot of people think about when they think of facial recognition, which is where you have an image of a face and you want to identify exactly who that face belongs to. Right. So you're trying to match that face to a database of ID photos or other images of people's faces that you have associated with their name. And that's the common use case that you might see in law enforcement when they're analyzing video footage to try to identify the thief, or in an anti-terrorism use case where they're analyzing airport footage to try to identify terrorists from a database. Those are a few different types of facial recognition. And facial recognition has recently come under, I think, very justified scrutiny because it in many ways violates core privacy rights that we all have. And so a lot of companies have withdrawn their participation in building facial recognition systems. Facebook most recently announced that they're no longer going to be doing facial recognition, which they were doing very innocuously to help you tag your friends in photos that you uploaded to Facebook. They would recommend a friend's name to be tagged. But of course, like any technology, that technology can be misused. And Facebook has now stopped using that facial recognition technology internally because they've come under so much hot water for general sort of making society a little bit of a more challenging place to live in. So I think facial recognition is an important thing for us to examine. There are certainly valid and important use cases. The most common one I give is if you have an iPhone and you use facial recognition to unlock your phone, you probably really appreciate that. If you're using the face detect, that's a great positive and straightforward way for you to unlock your phone without having to type. But it's definitely something that we need to watch out for use of in law enforcement and other ways that can violate our privacy.
Great. Well, thank you. Next question. Will quantum computing move artificial intelligence into new directions?
Great question. So I will admit, I'm not a quantum computing expert. I took a quantum physics class in college, and that's one of the reasons why I decided not to be a physics major. But quantum computing is really all about increasing exponentially the compute power that we have access to and the speed at which we're able to do computations. And so to the extent that we're continuing to train these really large models on tremendous amounts of data, a very compute heavy activity, quantum computing could improve that process, make it a lot faster and easier for us to do that training, less expensive. But to be honest, I think quantum computing has a lot more severe implications for the worlds of cybersecurity, because one of the main use cases for a huge amount of compute power is being able to brute force your way into a secure system. And quantum computing renders a lot of our current encryption techniques for cybersecurity obsolete because it makes it a lot easier, faster to break through those systems by just trying to guess. So that's the world that I think cares a lot about quantum computing. Not to say that quantum computing can't have an impact on AI, but it's not a major focus right now.
Okay, thank you. Next question from Tom and Lynn Bloomquist. Could reliance on AI degrade a human's problem-solving skills? Neuroplasticity, if you don't use it, you lose it.
Great question. This is where I think my earlier point about building AI systems that are really designed to help humans make better decisions is key. I think that we need to be designing AI systems that provide human users with a rich array of information so that human can make a better decision, as opposed to providing a simple yes/no answer and the human just clicks yes or clicks no. And so I'm not as concerned about humans losing problem-solving capabilities if we can really focus on building these AI systems that are interpretable, that explain why they're making a certain recommendation to a human, and that give the human access to some of that data that the AI system was leaning on to make that recommendation or make that prediction. I think the other area where AI is really being incredibly helpful and where this is not a concern is in tasks that humans just aren't very good at to begin with. I think all of us, if we were faced with the possibility of having a human look at a very complicated and difficult to read CT scan and maybe having a 75% capability of identifying the tumor in that CT scan, right, or having an AI system that has 96% accuracy analyze our CT scan, we'd probably all pick the AI system. And in this case, I think I'm actually quite hopeful about a future where we can delineate tasks between the ones that computing systems are good at, the ones that AI systems are good at, and the ones that humans are good at. And we can free humans to focus on the things that we're good at, the complex problem solving, the systems thinking, the relationship building. And we can do the sort of routine analytics, the analysis with computing systems that are much better at it than humans are.
Great. Thank you. And our next question, again, from John Beckwith. Deepfakes have a big impact on a person's ability to detect real and accurate information, which will in turn affect AI data. Is regulation planned around this?
Great question, John. Regulation needs to be planned around this. And there are a lot of active conversations. I mentioned the EU AI Act before. I mentioned the Algorithmic Accountability Act. There are efforts now to start to regulate this at the policymaker level. But this is where I think we also need to have industry come together and again define some of those standards about what is acceptable and what is not, because the reality is that the technology is evolving much more quickly than the regulatory landscape is designed to evolve. Regulations are designed to be a slow process, and so we need to come together to determine how to address these problems while the regulatory landscape still catches up. And this is where, again, I think we need greater leadership from organizations that have incredible AI research capabilities, the large tech companies, the large universities. We need these researchers to come together and help develop tools that will address the deepfake issue. There's been a lot of research in building deepfake detection systems that can do a better job of detecting deepfakes than humans can. There's been research in figuring out how we can, actually dismantle model-generated data. How we can detect it at the data level. So I think there needs to be a lot more work here because you're absolutely right. This is a critical issue for our democracy, for truth itself, and we need to figure it out quickly.
Great, thank you. And now, excellent question for this half of the broadcast. How can AI algorithms be ethical, and what metrics are used to measure it?
Great question. So AI ethics is a little bit of a wishy-washy term. I actually prefer the term responsible AI because ethics, as you've rightly identified, ethics tends to be something that varies from culture to culture, that varies even from individual to individual, whereas responsible AI has actually been fairly well defined by the research community. There are several tenets associated with responsible AI. Sometimes they come with different names, but the basic tenets are responsible AI must be fair, responsible AI must be transparent, responsible AI must involve accountability. There must be human accountability. And responsible AI needs to be fully monitored and evaluated for performance and other behaviors across the ML development lifecycle. And so this set of concerns really forms the pillars of how you do responsible AI development. And I'll dive into each of them. So fair, what do we mean by fair? Well, as I already discussed, there are many ways in which human biases can be ingrained or encoded into machine learning systems. And there are a set of techniques that machine learning developers can use to evaluate their systems for these different biases. And so a core tenet of responsible AI development is that you must evaluate your machine learning system for unintended harmful bias, for fairness. And if you detect an issue with fairness, there are a number of different steps that you can take to address or remediate that issue so that your system becomes more fair. And I won't get into the technical approaches now, but this is a space that is very actively being researched and further developed. And there are new approaches that are coming out all the time. So I'm quite hopeful that this is a huge area that's a big focus right now. I think a lot of us have heard of algorithmic fairness or algorithmic bias. But I'm quite hopeful that this is something that will do a much better job of solving in the near future because it's such an active research space. Now, the other component of responsible AI is transparent. So there are a couple aspects of transparency. One is, first of all, you want to make sure that the person interacting with the AI system knows that they're interacting with an AI system. The classic example of this is if you're interacting with a chatbot and you think it's a human agent, your trust is being violated. You don't realize that you're interacting with an AI system. And so the first tenet of transparency is making sure that your end users understand what they're interacting with. And then the second component of transparency is making sure that your end users understand exactly why that AI system is behaving the way it does. So for example, if I have a credit risk system that is predicting whether or not somebody should get a loan, I want to understand exactly what it was about my data that caused the credit risk prediction system to predict that they should decline my loan. And that is called explainability in many circles, AI explainability. And it's non-trivial because these systems are doing very complex math that often does not create a human interpretable explanation. So this is another very active research area where people are coming together to determine how to do a better job of explaining in a way that is meaningful to humans why complex machine learning systems behave the way they do. And then we talked about accountability. This is a really important thing that is actually a core component of what we're trying to solve for at Credo AI, is how do we make sure that all of these human decisions that are being made across the AI development lifecycle by the engineers, by the product managers, by the people who are determining how the system should be used, how do we hold people accountable for those decisions? How do we make sure that those decisions are encoded in our understanding of the system? Just like you read a nutrition facts label on your food and you understand everything that's contained within that food, can we have some kind of accountability label on a model so you understand all of the decisions and limitations that went into the development of that model and make better decisions yourself about how it should be used? This is a big space where I think regulation is going to play a huge role in helping to define those accountability structures.
Okay. Next question. How will AI affect the job market in the future?
Great question. I'm not an economist, but there is a general sense that a lot of new technologies that come to bear tend to create more opportunities in the job market than they destroy. This is not universally true, and it is certainly not universally true in specific communities. I mean, just look at the way that manufacturing becoming more roboticized destroyed opportunities in towns that had a factory in them. So I think the job market will be very unevenly impacted by AI. But I do actually believe that AI is going to create a ton of new opportunities. And this is where I think it becomes really important to make sure that the way that we're educating people matches the kind of work that people are going to be needed to do in the future. And I'm not just talking about STEM. Training students in science, technology, and math is really important. But training students in systems thinking, in the stuff that people are really good at, in relationship building, in how to actually learn as a human is incredibly critical. And so I hope that we can come together to really revise some of the ways that we're educating people to move away from the kind of analytical education where people are going to be, quite frankly, replaced by machine learning systems over time, and replace that training with how to train people to really be leaders, how to train people to think through complex problems, to train people to work together with technology to make better decisions.
Okay, so we have one last question from the audience, and then I'll have one more for you at the end. From the audience, for students or parents watching, how can they prepare themselves for a career in AI?
So there are a lot of resources out there to learn about all kinds of different aspects of AI. I think that it's really important to understand that there is no one career path in AI, just like there's no one career path in technology. Technology companies need salespeople. Technology companies need operations people. Technology companies need support people. And so I do think that there's a really great career path to be had learning how to become a machine learning engineer. But that's not the only path. And I don't think everybody should become a machine learning engineer, because probably not everybody is going to want to be a machine learning engineer. So my own path came from a world where I was really great at working with people and helping them solve problems. And I was great at learning how to understand technology. And I combined those two things to join the Watson implementations team and work directly with customers in a very hands-on way. I was not a hands-on keyboard programmer sitting there writing the code, but I was helping to translate the technical information into something that was meaningful to a business stakeholder. That's one option. But for those of you who really do want to learn the hands-on keyboard stuff, there are some great resources online. Coursera has a number of different courses that will prepare you very well for understanding how machine learning systems work. The best place to start if you have no background in this is a course called Machine Learning or Artificial Intelligence for Everyone. That's what it's called. And it's from Andrew Ng. He's one of the investors in my company, Credo AI, and he is deeply passionate about training people from all different backgrounds in how to understand AI systems. So Artificial Intelligence for Everyone, it's available for free on Coursera, and it's a great place to start.
Excellent, thank you. So we have one last question that we generally use for each one of our panelists. And you've already touched on this, but the question is, if you want our audience to remember one thing from this discussion, whether it's something you mentioned or something you hoped you would mention but didn't get a chance to, what would that one thing be?
Artificial intelligence is not magic, it's math. And quite frankly, it's not very intelligent. It's a pattern recognition system with very clear limitations and very powerful capabilities. And so whenever you're going out into the world and you are interacting with a system that brands itself as AI, or you're reading a headline about AI, I'd like to invite you to just replace those words, artificial intelligence, with pattern matching statistics, because that's really what it is.
Okay, thank you, Susanna. This has been a pleasure. I really enjoyed this conversation. So just a couple of things to wrap up with tonight. Reminder that the audience that you can rewatch this episode starting in about 5 minutes. If you go to our YouTube or Facebook channel, and you can also take a look at several years worth of Science Cafes that we have online there. If you see one you like, go ahead and look at it. Thank you to the audience for participating and for submitting some great questions. Really appreciate it. Thank you. A very special thank you to Susanna. Like I said, it was fascinating. I truly enjoyed the conversation, and I could have gone on for a lot longer than this. So we appreciate your time. We do not have a Science Cafe in December because everybody is busy. So we see you on January 19th for the next topic. In the meantime, we hope you and your family all have a great holiday season, a great New Year's, and we will see you later. For everybody, thank you so much for joining us, and have a good night.